In part 2 of lecture 7, we will look at an example of a derived class. As we said before, a derived class inherits all the properties and all the methods belonging to the base class. There is an exception to the rule. That is, methods defined in the base class that are overwritten in the derived class, which has its own methods by that name. Let's write the first derived class, HourlyEmployee. The class invariant, something that must be true throughout it, is that employees have a name, a hire date, a non-negative wage rate, and a non-negative number of hours worked. For the wage rate to be negative would mean that the employee is playing the employer, and that makes no sense. And there is no way that you can work a negative number of hours. The name string of no name indicates that no real name has been associated with it yet. Our header will be public class HourlyEmployee, and given that this is a derived class, we add extends employee. And now our two additional properties, private double wage rate and private double hours. And this will be hours for the month. Let's now write the default constructor, public HourlyEmployee. But before we do anything else, we have to call the constructor of the base class. Constructors have to be called explicitly. So by writing super the way we just did, it will call the constructor for the base class, which in this case is employee. Now we've basically set up name and date, but now we will add to that wage rate equals 0 and hours equals 0. Next we have the conversion constructor. The same preconditions as before. Public HourlyEmployee, string the name, date the date, double the wage rate, double the hours. And again, we will use the conversion constructor, this time, for the base class. And we write super, the name, the date. This way we have taken care of initializing these two properties that it inherited from the base class. Now, let's see about setting values for the properties belonging specifically to the derived class. If the wage rate is greater than or equal to 0, and the hours are greater than or equal to 0, then we know we have valid values here, and we set them. Wage rate equals the wage rate, hours equal the hours. If that is not the case, we will have printing out, system out println, fatal error, creating an illegal HourlyEmployee. We split this into two strings so it fits on the slide. System exit 0, and then we are finished with the conversion constructor. The copy constructor is fairly straightforward. Public HourlyEmployee, HourlyEmployee original object. We will first call the copy constructor belonging to the base class, super original object. Then afterwards, wage rate equals original object dot wage rate, hours equal original object dot hours. We see here the first two accessors, public double get rate, which will return wage rate, public double get hours, which will return hours. And get pay, this accessor is a bit different because what it's returning is something that is not actually a property of the derived class. What it is a value that we can find directly from its two private properties. Public double get pay, and it will return wage rate times hours. Here we can set the first of the two properties with a mutator. Set hours appears below, and again, hours worked must be non-negative. Public void set hours, double hours worked. Well, if hours worked is greater than or equal to 0, hours equal hours worked. Else, system out println, fatal error, negative hours worked, system exit 0. If the hours are negative, we'll print an error message and quit the program. Now, let's write the mutator for wage rate. And again, the same condition, new wage rate, the new value, has to be non-negative. Public void set rate, double new wage rate. If new wage rate is greater than or equal to 0, wage rate equals new wage rate. Else, system out println, fatal error, negative wage rate, system exit 0. We complete the class by writing the last two methods, toString and equals. ToString will overwrite the base class's version of the method. Public string toString, return getName plus blank plus getHigherDate dot toString plus new line plus wage rate plus per hour for plus hours plus quote hours unquote. This will create a string out of the individual properties belonging to the class, and we can use this in many applications. Equals becomes public boolean equals hourly employee other, return getName dot equals other dot getName, and getHigher dot equals other dot getName, and wage rate equals other dot wage rate, and hours equal other hours. Let's now write the default constructor, public hourly employee. But before we do anything else, we have to call the constructor of the base class. Constructors have to be called explicitly. So by writing super the way we just did, it will call the constructor for the base class, which in this case is employee. Now we've basically set up name and date, but now we will add to that wage rate equals 0 and hours equals 0. Next we have the conversion constructor. The same preconditions as before. Public hourly employee, string the name, date the date, double the wage rate, double the hours. And again, we will use the conversion constructor, this time, for the base class. And we write super, the name, the date. This way we have taken care of initializing these two properties that it inherited from the base class. The slide shows what the output is going to be from the demo program. Joe's longer name is Joe Worker. Changing Joe's name to Josephine. Joe's record is as follows. Josephine, January 1st, 2004, 50.5 per hour for 160.0 hours.